Isn't a perfectly clear sky just so beautiful? Why does the sun look so small though? Wait, what? So basically, we're going to see what it would look like on other planets, starting with the closest to the sun, Mercury. So here we are on Mercury. That's a bit bright. Let me turn down my exposure. The sun obviously appears much larger here than it does on Earth, and thus much brighter. Mercury has no atmosphere, no moons, and some very extreme temperatures. Daytime temperatures can reach highs of 430 degrees Celsius, with nighttime temperatures dipping down as low as negative 180 degrees Celsius, the average temperature being 167 degrees Celsius. Why do I sound like the weather radio? Anyway, Mercury makes one full rotation in about 58 Earth days, which is a pretty long day. But because Mercury orbits the sun so fast, about once every 88 Earth days, the actual day length on Mercury is 175 Earth days, which is a very long time for a single day. Imagine working 2,800 hour days. Or since a year on Mercury is shorter than its day, imagine working 1.3 year days. What? This odd effect also causes the sun to briefly appear to reverse direction during the day. If you know anything about the solar system, you know which planet is next, and that is Venus. Unlike Mercury, Venus has an atmosphere, and a thick and deadly one at that. The atmosphere is mostly carbon dioxide with clouds composed of sulfuric acid. This is literally the image you get in your head when you think of a deadly planet. In fact, it's so deadly that out of the 10 landers which have successfully landed on Venus, most lasted less than an hour, and the longest time survived was just 2 hours and 7 minutes. When you have hurricane force winds, atmospheric pressures equal to being 1 kilometer underwater, and temperatures hot enough to melt lead, let's just say even electronics don't really stand a chance. But Venus is special for more reasons than just being incredibly hostile. From Earth, Venus is the third brightest object in the sky, with only the moon and sun being brighter. At night on Earth, if there's no ambient light, such as the moon, Venus is actually bright enough to cast shadows. And I was even able to photograph it during the middle of the day once. Speaking of brightness, this is what it would look like here at our normal Earth exposure. Venus is also special because it's the hottest planet in the solar system, is almost the same size as Earth, and it spins backwards, making the sun rise in the west and set in the east. Not that you could see it very well since the atmosphere is so dense. But anyway, onward to Earth. That sounds strange. Most of us know what this looks like already, so it's actually a bit boring compared to what we've just seen. Not to mention the fact that my 3D modeling skills are kind of terrible, so this looks pretty bad. Average temperatures are about what you'd expect. There is one thing that's quite a bit different about this planet than all the others, and that is, of course, life. The vast amount of life forms on Earth, as well as their vastly different and often unique designs, are what really make this place stand out from the rest and feel like home. Unlike the other planets, Earth isn't quite so hostile. I take that back and we're moving on. Here we are on Mars. This planet has been studied quite a lot. The temperatures range from negative 153 degrees Celsius at night to 35 degrees Celsius during the day, with the average temperature being around negative 63 degrees Celsius. Mars is special because its day length is just 40 minutes longer than Earth's day length of 24 hours. Oh, and Mars has 2 moons, Phobos and Deimos. Phobos orbits Mars faster than Mars itself rotates. This makes it appear that Phobos rises in the west and sets in the east, i.e. it appears to go backwards in the sky. Also, quick Earth exposure as a reference before we continue. It is starting to get noticeably darker as we get farther from the sun. Quick side trip while we're looking at stuff, this is the sun from Ceres. Not anything particularly special except that it is getting noticeably darker, but just for anyone curious, this is about what it looked like. You'll notice that you can't really see any other asteroids, and that's simply because despite there being millions of asteroids, the asteroids are spread out over such a large area of space that the distances between them are extremely large. This is why we can send spacecraft through the asteroid belt with basically no worries of it colliding with an asteroid. Anyway, on to Jupiter. This is our first gas giant, so there's technically no surface, you're just levitating in the air, or whatever you want to call this stuff. We're now 5 times farther from the Sun than Earth, so it is considerably darker, which basically means I need to boost my exposure so that we can actually see stuff. You might have noticed that it's incredibly windy here, and that's a trend you'll notice with all the gas and ice giants. The temperature here averages about -108 degrees Celsius. Jupiter is very special, being the largest planet in the solar system and spinning the fastest, with a day lasting just under 10 hours. Light from the sun takes over 43 minutes to reach Jupiter. If you didn't know that, I'd recommend going and watching my 9-hour-long video. Guess what? It's Saturn time! With a fairly major exposure boost, this planet will give you perhaps the most interesting view, with the rings looking so incredibly beautiful and dreamlike. It's almost hard to believe that this is real. Well, I mean, it's not. Well, it is, but it's like not this video. Whatever. The average temperature here is about -139 degrees Celsius, and Saturn has the most moons of any planet in the solar system. 146 moons. Gotta take at least a minute to absorb this incredible view though, am I right? Ha! Nope! We've got more planets to go. I can literally barely see. But here's the Sun from Uranus. The average temperature here is about -197 degrees Celsius. Uranus holds the record for the coldest recorded temperature out of all the 8 planets. Neptune is still colder on average though. And here we are on Neptune, the last of the 8 major planets and one with some terribly fast winds. These winds whip clouds of frozen methane across the planet at speeds of over 2,000 kilometers per hour. The average temperature here is about -201 degrees Celsius. The average brightness here, in the middle of the day, is very low, being about 9,000 times darker than noon on Earth. Let me reset my exposure to what we used on Earth so you can see just how dark it is here. At this distance, the sun is so tiny that it's almost hard to believe we're orbiting it. Before we end, let's take a quick peek at the last 4 dwarf planets just for fun. This is Pluto. It's very dark here. This is Haumea. Also very dark, who would have guessed? Oh, and I should probably specify that we don't actually know a whole lot about these last 3 dwarf planets, so this is about what it looks like, but it might also not be. Here's Makemake, not too much farther than Haumea and Pluto. And lastly, Eris, over 10 billion kilometers from the sun. It's basically the middle of space now, or at least it sure feels like it. But that's basically it. You know, if this video wasn't boring enough for you, you could go and watch my 9-hour-long video